Okay, so in this video, I'm going to show you how to figure out the upper half of the unit circle, and then I will leave it up to you to see if you can figure out the bottom half of the unit circle. So let's get started. First of all, what I do is I tend to label the special angles of a triangle. And you may remember from integrated 1 or 2 that there are some special angles in geometry. So we start off at, of course, 0 degrees here. And then the next angle up is the 30-degree angle. Followed by the 45-degree angle. Then the 60-degree angle. And takes care of the first quadrant. And then you just keep going, following the same pattern. So let's see. I know that this point here is straight across from this point here. So let me just kind of put some dots there so you can see what's going on. And since this is between 60 and 90 is 30 degrees, and I know I have 30 degrees between those 2 points. So this has to be 120 because 90 plus 30 would be 120. And then I have 45 degrees and 60 degrees here, which has a difference of 15 degrees. So if I go 15 more degrees over, this is going to be 135 degrees. And I know that this point here is opposite this point over here. And this point on this side is 30 degrees up. So I know that I need a point on the opposite side 30 degrees above the x-axis. And I know that there are 180 degrees in a straight line. So if I go up 30 degrees, then I know this has to be 150. Okay. Now we know that we have special right triangles. In other words, if I drop an altitude here, I can create a right triangle. And if I drop an altitude from the 45-degree mark, I can create another right triangle. And we can continue this, right? We can drop from 60 to create a right triangle. And you may remember that there are some special side lengths that go with the 30, 60, 90, and 45-degree angles. If not, then I'm going to show you just a very quick way to memorize the pattern here. We start off, we know that this is a unit circle, which means that the length of the radius is 1. So if you go from the center of the circle all the way over to this side, the radius is 1. That's why it's called a unit circle, because the radius is 1 unit long. So if you start from the origin and you go over to the 0-degree mark, then you have landed at the point 1, 0. And at the 90-degree mark, you are at 0, 1. And if you go to the 180-degree mark, you are at the point -1, 0. Now, I bet you could figure out this point here. But again, I'm going to leave the bottom half of the circle for you to try to figure out. Okay, so I know that I go from, if I start at 0 degrees and I move counterclockwise, stopping at the 90, I know that x goes from 1 to 0, which means I have to count down as I move. So what would I get here? What would this value here be? What would this value for x and y be for this coordinate here? That's the question. And then as I continue to move up, what would I get for x and y? And there is a pattern that emerges. So let's look at the pattern. Well, I'm going to write the square root of 3 divided by 2 for the x value. And I'm going to do 1/2 here for the y value. So notice that as I moved from 0 degrees to 30 degrees, the x value got smaller, but the y value got larger. And that's going to continue as we move all the way up to 90 degrees. So let's let the x value go down as we move up to the 45. Well, it's going to go down to the square root of 2 over 2. And the y value will be the square root of 2 over 2. If we move up to the 60-degree mark, we end up with the square root of 1, which is just 1 over 2. And notice that y becomes the square root of 3 over 2. Okay. Now, if we could just memorize this first quadrant here, we can actually generate all of the necessary coordinates for the entire circle. Okay, so let's see if we can go back and look at this pattern again, because I really want you to see this. Okay, so we start here at 1, 0. And again, we know that when we get to the top of the circle, x has gone from 1 to 0, right? So x is getting smaller as we move, but y starts at 0 and ends up at 1. So y is getting larger. So we go from 1 to the square root of 3 over 2 for x, square root of 2 over 2 for x, square root of 1, which is just 1 over 2 for x. In other words, x counts down 3, 2, 1, 0, but don't forget the square roots on top, right? And notice that all of the denominators are 2. So we go from x is the square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and then we go to 0. And notice that y and x switch, but they're exactly the same here at 45. So at 45, x and y are the same. And they switch as they move around. In other words, here, y is 1/2, and up here, x is 1/2. Down here, x is the square root of 3 over 2, y is the square root of 3 over 2. And that's because they are working opposite each other. So that's how you can memorize the coordinates of the unit circle for the first quadrant. So how would we figure out the coordinates between 90 and 180 if we just memorize that upper quadrant? Well, let's do the rest of these. If I go from 90 to 120, then that's going to put me at this point here. At 120, the point is going to be exactly the same height above the x-axis. In other words, the y value is going to be exactly the same as the y value opposite. In other words, if you look straight across here, that y value has to be the square root of 3 over 2. The x values are not exactly the same because we're on opposite sides of the y axis. So the x values on the left side have to be negative. So that's going to be negative 1/2. What about the 135-degree mark? Well, 135 degrees is opposite 45 degrees. Again, the y values are the same, square root of 2 over 2, but the x values are now switched. So that's going to be minus square root of 2 over 2. And again, I apologize for the handwriting. I am still waiting on my digital pen. Evidently, they are suddenly in great demand. So there we go, minus the square root of 2 over 2. And finally, we will do the 150 mark here. And notice that 150 is directly across from 30. So the y value is going to be 1/2. And the x value is going to be opposite, minus the square root of 3 over 2. Okay. So how would you get the points at the bottom? Well, you just have to reflect those points through the x-axis, which means you have to make sure that your y values are now opposite each other. But I will leave that to you as an exercise. So let's answer some questions. First of all, we know that we could do degrees, which we have, or we could do radians. So let me put some radian measures up here. We know that 60 degrees is actually pi over 3 radians. We've learned that already, so I'm going to say you already know that, right? And I know that 90 degrees is actually pi over 2 radians. And we could figure out that, let's see, 150 degrees, 150 degrees multiplied by pi, and then divided by 180, looks to me like that's going to be 5/6 pi, 5 pi over 6 here, radians. Okay. So now, since we know the unit circle, we can answer quite a few problems. For example, if they want to know what is the sine of 30 degrees? Well, remember, sine is going to be the x value on that coordinate. So if you look at 30 degrees, notice that the y value is 1/2. So the sine of 30 is 1/2. And since 30 degrees is the same thing as pi over 6 radians, we could say that the sine of pi over 6 is also 1/2. So the sine of pi over 6 radians is 1/2. What about the cosine of pi over 3? Well, the cosine of pi over 3, remember, cosine has to do with the x value. So if you go to pi over 3 or 60 degrees, notice that the x value is 1/2. And let's do one more. Suppose they want to know what is the cosine of 150 degrees, or they could say 5 pi over 6, right? So the cosine of 5 pi over 6 is going to be the x value, and that's minus the square root of 3 over 2. Okay, so that's just a few examples of how we can use the unit circle conveniently to answer questions, especially if you have a professor who says, hey, on our tests here, we do not use calculators, or maybe we have a non-calculator portion. And if you do not know the unit circle, you're going to be in big trouble. So try to memorize the unit circle, or at least the pattern. Remember, if you can generate the first quadrant, then you can just flip everything to the opposite side to do the second quadrant. Then you can flip all of that down and do the third quadrant and so on. Let's do one more thing here before we stop. We know that tangent is opposite over hypotenuse. Tangent is the y value divided by the x value. So if you look at the tangent of pi over 6, for example, the tangent is going to be the y value, and remember pi over 6 is going to be at 30 degrees, and the tangent again is the y value, which is 1/2, divided by the x value, which is the square root of 3 over 2. Luckily, I can cancel out the denominators here, and that would give me a final answer of 1 over the square root of 3. And we do not normally leave denominators like that. We typically do not like radicals in the denominators. So we do what they call rationalizing the denominator. We multiply the fraction by 1, but we write 1 in a special way. In this case, we're going to do the square root of 3 over the square root of 3. And if I simplify this, I end up getting 1 times the square root of 3, which is the square root of 3. And then on the bottom, I would have the square root of 3 times the square root of 3, which is the square root of 9. And the square root of 9 is 3. So the tangent of pi over 6 would be the square root of 3 over 3.